Hi everyone. During this session, we'll demonstrate how to utilize the Azure Defender for IoT features and tools to conduct a thorough forensic investigation of network security incidents. Embedded in Azure Defender for IoT platform is a rich set of forensic investigation capabilities, which are interconnected and complementary in a way that allows the user quick navigation between the different views and insights. These tools can be used to explore security and operational events in your network by collecting evidence and sharing information. This session will help you analyze and understand network behavior and determine the root cause of anomalies. Using this tool, the analyst can determine if an event is a security incident, operational fault, configuration issue, or expected network and equipment behavior. During this session, we'll explore and demonstrate the use of forensic tools, which include network topology and assets inventory, alerts, event log, data mining, investigation widgets, and attack vector simulation. Now, let's start by overviewing the set of forensic features. A devices map is automatically generated by Azure Defender for IoT. As we zoom in, we see more detail on assets. By selecting an asset and clicking on the Eye for Information icon, we're presented with more detail on the asset. Open the Groupings section using the hamburger icon on the top left of the blue bar. This view allows the user to analyze asset communication and properties based on various groups and filters. For example, groups of different protocols, applications, subnets, or VLANs. In this case, we have filtered on the BACnet protocol, showing only devices using this protocol. Use the information you learn in the Assets view to get a comprehensive understanding of network security issues by reviewing related alerts, events, and activity. By combining this set of tools during incident investigation, the user can achieve a comprehensive view of the network behavior. Azure Defender threat detection is based on self-learning engines and network traffic analysis. Azure Defender triggers alerts based on policy violations, protocol violations, network anomalies, malware, or operational events detected in the network. System alerts can be forwarded to SIEM systems or firewalls. Forwarding rules can define the alert text, severity level, protocol, engines, actions, and more. Alerts detected can become a trigger for further analysis and deep dive investigation. Important information is presented in the alert, including the assets involved, a description of the incident, and mitigation recommendations. Administrators and security analysts can add comments to the alert to expedite incident management. From the alert window, the user can navigate to the event timeline, can download a filtered or raw PCAP using the icons at the top of the alert window. By clicking either of the devices which are the subject of the investigation, the system quickly navigates to the asset view, where he can find additional details regarding the asset properties and connections, and from these to view events history on the event log and so on. This feature lets you review the events in context and event history on a timeline. The alerts in the event log include related PCAPs, which can be downloaded for further investigation. The log supports searches with various filters to allow focused investigation. Event logs can be accessed directly through the bar on the left or navigated from the alert view. Data mining lets you create reports based on various categories and filters. A standard report showing remote access can be very valuable. Data mining reports can provide a broad view into the network, or specific insights into generic network information. Database operations, open ports per connection, assets activity, OT protocols, and much more. It is also possible to mine based on group, IP address or subnet, port, or MAC address. Data mining can be accessed directly through the bar on the left or navigated via the Properties bar in the Devices map. You can create custom dashboards that include graphs and charts. These can provide trends and statistics on threats and anomalies in the network. Standard pre-built widgets are included, such as bandwidth peaks, traffic distribution by port and protocol, new devices, busy devices and channels, incidents by type, and more. This tool lets you simulate attack chains and the impact of mitigation activities. For example, by handling certain vulnerabilities, an attack vector can be reduced or eliminated. In this case, for instance, the resolution of the plaintext FTP password associated with 192.168.88.49 can resolve all three attack paths to the PLC. Now let's review some forensic investigation examples. Use case example number 1, NotPetya. During daily operations, users observe an alert indicating suspicion of NotPetya malware, illegal SMB transaction detected. Upon receiving this alert, the SOC analyst will probably decide to continue the investigation. The alert may be reflected in the customer SIEM application, as defined by the Azure Defender for IoT forwarding configuration. When the alert pops up in the SIEM and the SOC analyst notices it, this could be the starting point for the investigation. The SOC analyst may decide to drill down to the sensor that generated the alert. Opening the alert provides full detail on what the Azure Defender for IoT sensor found. As mentioned before, the SOC analyst can dig deeper and download a recorded PCAP, which is embedded within the alert. Key indicators of NotPetya are use of SMB. Using this protocol, the client negotiates a session connecting to an IPC share on the malware host, which is usually a hard-coded address. Notice the path to this IPC share on 192.168.92.31. Next, the malware sends out an initial and secondary NT transfer request, delivering the malware payload as shown. At this point, the analyst can proceed to investigate the context of the alert. This investigation could evolve and include other events that might be related. Through the event log located here on the main bar, the analyst can understand the event context and see alerts, events, and user actions created before and after the incident. The user can navigate through the alert view or directly from the main bar to the event log to see the alert on the timeline. During the investigation, the user can choose to explore the incident on the asset map view. By clicking the assets in the alert, the user is navigated to the assets view, in which the relevant assets are highlighted. Assets properties are displayed in the information sidebar. In addition, users can choose to view the relevant connection details. This way, the analyst can correlate the information and surmise what occurred in the network from a broader perspective, and not just the device. The analyst can expand the investigation and generate a new report under data mining. This report can present SMB logins, filtering the relevant device group or IP addresses or additional activities of the suspected device. The user can also generate another report showing all the traffic using the suspicious IP address. This way, we can see all the activity of the device and learn if there was other suspicious or malicious activity from the device. By using and navigating between different views, the user can gather as much information regarding the incident as needed. From each view, export options are available for documentation and sharing purposes. Use case number 2, OT network misconfiguration. Here, the user noticed a spike in traffic. Observed bandwidth peaks or unexpected bandwidth should be investigated further. Peaks may indicate misconfiguration or inappropriate usage of data. With the Azure Defender for IoT platform, the user can create customized dashboards with various graphs and charts to describe the monitored OT network status and behavior. An example for a useful view is the total bandwidth widget. This widget describes the total bandwidth of the network as well as the highest channel bandwidth for a specific time. When bandwidth peaks are detected, it's recommended to check what the busiest channels are by adding the channels bandwidth widget. The analyst can now discuss the behavior with the plant control engineers and determine if this is correct or not. Additionally, by hovering over the channel to see which ports are used between the endpoints, plant control engineers should be able to tell if the behavior is as expected. An additional option is to generate a custom alert with the specific source and destination channels with a relevant communication protocol filter, and by that capture a PCAP of the traffic for further analysis. Generating a custom alert is done by clicking the Custom Alerts tab. To add an alert, click the plus sign in the left corner and simply insert the relevant parameters, name, source, and destination addresses, and determine the rest of the parameters of this custom alert. A good example in this case is that the referred device is misconfigured, and after mitigation and reconfiguration, the user can verify that the bandwidth dropped and is normal. I'd like to thank you for joining me in this session. In this session, we saw how to conduct forensic investigations using Azure Defender for IoT's rich set of forensic investigation tools. We look forward to seeing you in our next session.